Can you tell me what is a chemical chain? Chemical reaction, basically. Chemical reaction.
So chemical reaction is when two um it is when two uh, uh, well so a chemical reaction
It is when
is
two substances they react to form a product, right?
when the molecular arrangement is rearranged.
Yeah, so now can you tell me one thing? What are the different signs uh, that you look whether the chemical reaction has occurred or it has not occurred? How will you get to know? Yeah, there's a chemical reaction. How will you get to
So
know?
there might be a huge flame,
Huge flame, okay.
or there might be like a smell, a scent.
Okay, smell can be there. That means a smell of the gas, you can say, which has been released, right?
Yeah,
Yeah. And
and
second, yeah,
as well there could be like the color might have changed,
excellent. The color might have changed.
as well as um
Like sometimes the energy is being given out. We call it as the thermal energy, right?
oh yeah, yeah,
Yeah, or something you can say the light is being produced. The light energy is being produced, right?
yeah.
Yeah. So now what are exothermic and endothermic reactions?
Endothermic reaction is when from the
Right.
from the substance it is the substances no the surroundings are transferring energy to the substance.
Okay, so basically the energy is being absorbed, right? To
Yeah,
carry out a chemical reaction. And in exothermic, it is the opposite. The energy is being released,
yeah.
right? Right. So now, if I ask you, like we have discussed that there are some chemical reactions which were useful and which are not very useful. Can you tell me some useful chemical reactions? Can you give me
So
the example of them? The name of the reactions?
so cooking
Cooking. Okay.
react the reaction that happens in your car engine
Okay.
as
The
um,
common examples which I told you last time. I told you about the neutralization reaction. Neutralization.
yeah
Yeah, what
um
happens? What is neutralization reaction?
so neutralization reaction is when you want to add base to acid and acidic.
Excellent. Right. And for example, is like if you see neutralization reaction happening in our stomach, it removes the stomach acid, right?
Yeah.
Yeah, the other examples are smelting. What was smelting?
So smelting is when you smelt all the ores.
So, okay, smelt or the ores, but what is smelting? Right, that is what I'm asking.
So smelting
How will you define the word smelting or the smelt? You can say
so
it is basically when you extract a metal from the ore, right?
yeah.
Yeah, but
Yeah.
what is ore basically? See, if you see in the earth crust, the metal is not available openly. It is in the you can say it is present as an ore. Ore is what basically it's a solid rock kind of a thing. Inside that the metal is there. Okay, so when you have to extract that also, there is a chemical reaction which is occurring. Right.
Okay.
Okay, and tell me what about the fermentation?
So
Ferment.
fermentation.
Yes.
So it's microorganisms. So they do an anaerobic reaction. So
Excellent.
it's in the it occurs in the microorganisms when making bread. beer and wine.
Okay, you can't say that it happens in the microorganisms. See, now you have sugar. Okay, I'll give you an example of sugar. What happens when yeast acts on it and it occurs in the anaerobic condition? That means no oxygen is there. The sugar gets converted to the ethanol and the carbon dioxide. You understood?
Yeah,
Sugar gets converted to the ethanol. Ethanol is what? Alcohol
yeah,
and carbon dioxide. Did you get it? And we
yeah.
also have some more useful reactions, chemical reactions, if you know. What is combustion? Combustion is basically addition of the
A
oxygen.
burning
Yeah,
reaction,
you have
oxidation.
given the example like of the fuel with the oxygen, right? So,
Yeah,
yeah, carbon dioxide, water, and energy is being released. We have respiration. So, what is respiration? That is also sugar plus oxygen, which gives you the carbon dioxide plus water and energy is being released, right?
yeah,
Yes, yes. And if you see glues and additives also, adhesives, what are those? They form a bond actually between the materials, right?
yeah.
That is why we call it as contact adhesive also. So now if you see, these were the some chemical reactions which are very useful, but we also have certain chemical reactions that are not useful. Can you name them? Can you name any of them?
Um, so, uh,
If you see corrosion, I told you corrosion. What is
oh yeah,
rusting of iron, right?
yeah.
Right?
So as well as oxidation. So in the car, when when the metal reacts um, with the oxygen, it rusts.
Okay, on the car basically. Right?
Yeah,
Right. Okay. And then if you see, what about pollution? Pollution is also an example of the, you can say, a chemical reaction which is not useful, right? And we have discussed about the acid rain, if you remember.
yeah. So that's when all the what do you call all the so when factories the
Excellent.
the pollution, it rises up and condenses to form clouds, and there it produces acid rain,
Yeah, so
which
how
can
it produces, basically what happens is there are factories, they release certain harmful gases like sulfur, nitrogen. Now when they go up in the atmosphere, they react with the oxygen. Now when they have reacted with the oxygen, now they have come in contact with the water droplets which are present in the clouds, right? And then what happens, then rain happens, and all the acid rain, you say, that falls back on the earth's surface. Now when it falls on the earth's surface, it basically, you can say, cause breathing problems, that is irritating our lungs. And it also damages the leaves on the trees, you can say. And in fact the infrastructure also gets, it basically disrupts that, damages that. You understood? Yeah,
yeah.
okay. And what about the greenhouse effect?
Greenhouse effect is when the carbon dioxide forms a layer um, over the Earth's atmosphere, and when the sun's rays shone into the Earth, it like it bounces back and forth between the Earth.
Okay, so what is the harmful effect of the greenhouse effect? Can you tell me?
So it's harmful as it heats up the Earth.
Okay, so basically the global warming is been happening, right? The
Yeah,
melting of the glaciers, if you see, and therefore there is a rise in the sea levels. And if you see, there are certain places where so much of wind is there, droughts are there, cyclones are there. So all these changes, it is because of the global warming only, right?
yeah,
Yes. So now is it clear to you till now? So now,
yes.
yeah, and now can you tell me what was conservation of mass during chemical reaction? What is conservation of mass?
Conservation of mass is So the
That the total mass of the reactants is equal
yeah
to the total mass of the products, right? Right?
yeah
So whenever
yeah
you suppose you add some X chemical with Y chemical and you make Z chemical, what happens? The mass of these two reactants will be equal to the mass of the product,
hello
right?
hello hello
I was telling you, like, if there are reactants and if there are products in the reaction, suppose these are X and Y are the reactants and that forms Z products, so that means the mass of X and Y is equal to the Z, right?
yeah okay
Yeah. So now anything, whatever is given to you reactants, and if products, the mass should be same. If I say, okay, I give you a chemical, we call it as potassium iodide. This is X, and Y we have lead nitrate solution. So when you mix it, can you tell me what is the weight of the product according to the conservation of mass law? Then you say, in the conservation of mass, the mass of the reactants is equal to mass of the product. So you're going to add both of them and you're going to tell the mass of the product. Is it clear to you?
yeah
Yes. So now we have also discussed about the burning also, right?
yeah
We did the experiment also. We showed a diagram where a candle was there, if you remember, and soot was produced, and then what the products were the water and the carbon dioxide, and we did tests to see that, right?
yeah
So now let's continue the topic from here. Now we are going to discuss about the fuels. Now, can you tell me what are fuels? Do you know anything about fuels?
um yeah so fuels are a source of energy
Okay, very
um,
good.
that are
So,
used
yeah,
in combustion reactions to produce energy.
excellent. So now if you see, it is all, you can say it's a big chemical change also. Chemical reaction is been happening, right? And
Yeah,
whatever the energy is being given out by these fuels, that is quite useful for the humans also. Like we can produce electricity also, right?
yeah,
Yeah. So now, and the best thing is, like, if you talk about electricity, electricity can be produced at one place and it can be supplied to the different places, right?
yeah,
Yeah, so that means, from, if you see, from through fuels we are creating energy at one place, and from there the energy is being distributed to different places. You can say through the wires, the electric current is passed through the wires. So now this means, if you see, our lives, they are becoming cleaner and more comfortable also, right?
yeah.
Yes. So now, can you tell me, these were related to the fuels? Like, okay, it's a chemical change, you can say, and it's a chemical reaction, and through that, you just, I'm giving you an example to produce electricity. We have more examples. Through fuels, we can produce thermal energy, right? We can
Yeah,
produce light energy also. So similarly, we could produce the electricity, which I gave you example, and we can do the distribution also. So now let's talk about the combustion and the environment, that is the problems which are happening with the fossil fuels. Now first you have to tell me what is a fossil fuel.
so fossil fuel is a non-renewable source of energy that can be found under the Earth's crust and deeper down.
Yeah, so basically they are the remains of the dead and decaying matter, right? Dead animals and plants also. So
Could you?
So we were talking about the fuels. So now you see the thermal fuel, the thermal energy is being produced, light energy is being produced. If you see, it produces electricity from at one place, and then we do distribution of the electricity to different places. And this shows that, see, it is, the life is so comfortable and convenient that it can be supplied also, right, to the wires, if you see, through the electric current. So now let's talk about the fossil fuels. Now you know that fossil fuels, they are basically the fossil fuel, they are basically the dead remains, you can say the dead remains of the plants and animals, right? There are three fossil fuels. Can you name them?
Natural gases,
Right, natural gas.
nuclear waste.
Uh, Not exactly. We say the coal and the crude oil, or the oil also you can say. Okay.
Oh, okay.
Yeah, so these are the fossil fuels, you must know that. And these fossil fuels, they contain many of the chemicals. Okay, what,
Hmm.
like if you see when the plants they are alive, so now and the plants or the animals when they're alive, whatever chemicals they have, so now when they're you can say when they're dead, so all those chemicals they are present in them, right?
Yeah.
So now if we talk about those chemicals, can you tell me those chemicals are made up of which elements?
Um, CO2.
Carbon, hydrogen, sulfur, you can say, nitrogen. And in fact that is why we always say that the plants and animals, they are the organic material. Why we call them organic material? Because they have
They
the
like.
right, yeah, these elements, right?
Yeah.
So now when you burn a fuel, what happens? Burn a fuel means when combustion has happened. When combustion has happened, what happens? What is combustion?
So when you burn a fuel.
Yeah, when you burn a fuel, or you call it as a combustion. What is combustion? When you react something with the oxygen, right?
Oh,
Right?
yes.
Yeah, what is
Oh,
combustion? Anything in the presence of oxygen, when you burn something in oxygen, right?
it's a byproduct of carbon dioxide.
Right, okay, right. So now when what happens is when these fuels they are burned, like we have these elements, right? When they are burned in the presence of oxygen, then what happens? They form basically the oxides.
Yeah.
Yeah. So yeah, so like if we say about carbon, carbon combines with the oxygen to form carbon dioxide, right? So if you
Yes.
see nitrogen, we have nitrogen. So now nitrogen reacts with the oxygen to form nitrogen oxide, you can say, right?
Yeah.
Yeah. Nitrogen dioxide, it will form nitrogen dioxide. You understood? Similarly, if you talk about sulfur or you talk about hydrogen, sulfur will give sulfur dioxide, right?
Yeah.
Plus O2. So now let's talk about this is S. So let's talk about hydrogen. When hydrogen reacts with oxygen, what does it give?
Uh, um, Oxygen. I'm not sure.
Water.
Oh, yeah. I'm sorry.
Okay, yeah, water. And let's talk about the other fuel. This thing also. If you talk about see these oils and all the gas containing hydrocarbons, they have the natural gas, right? The natural gas, it has the main ingredient, you can say the main hydrocarbon. We call it as methane, right? In natural
Yeah.
gas, you have methane as the main hydrocarbon. Now, when this reacts with oxygen, what happens? Carbon dioxide plus water is being formed.
Okay.
Okay, you
Yeah.
understood?
Yeah.
So now, yeah, you have to balance the equations always, right? So,
Yeah.
is this clear to you?
Yeah.
Yeah, you want to take the screenshot?
Okay. Yeah. I'm taking the screenshot.
Yeah. So now let's talk about, see, if you see, if there is too little oxygen present in when fossil fuels they burn, what will happen? Like now, right now, I have given you a reaction when carbon is burning in combustion is taking place. That means in excess of oxygen it is there, and then it forms carbon dioxide, right? This is when oxygen is in excess.
Yeah.
Okay, now what happens when oxygen is not in excess? Can you tell me? The carbon will react with oxygen, okay, when not excess, when it is not present in excess, what happens? It forms carbon monoxide. You understood? If like you just
Oh,
balance it
okay.
like this, okay,
Yeah.
instead of carbon dioxide, carbon monoxide will be formed. Now if you see this gas, okay, I'll give you an example. It is always said that when the car is on, or when the AC in the car is on, the person is
Yeah.
not supposed to sleep in the car, right?
Yeah.
Yes, why the person is not supposed to switch on the AC in the car and sleep at night? Because it forms carbon monoxide. Now, this way, the carbon monoxide will basically go in the red blood cells in the blood, and it will
Will
not
it
allow,
actually
right, to take the
oxygen?
oxygen around the body, right? And yeah, the person can die also.
Yeah.
Yes, now is it clear to you? Because their oxygen is not in excess. So carbon monoxide is formed. Just give you an
Okay.
example, right? So now if you see, if you burn the fossil fuels, so what happens? A lots of energy is being released, right?
Okay.
So but burning the fossil fuel, if you burn the fossil fuel, burning the fossil fuel has two problems. Can you tell me those two problems? There are two problems for that. The first one, we say that fossil fuels, they are non renewable. So if they
So if
get
they run
finished,
out,
yes. So what will happen?
there will be no more non-renewable sources left.
Yes. And second thing, when you burn them, it emits lot of energy. We can also say that it causes pollution also in the
Okay.
atmosphere, right?
Yeah.
Like there will be smoke, ash, water gases. So now what is going to happen? See, when you burn fossil fuel, so lot of gases they emit in the air also, causing air pollution. If you see, smoke is there, ash is there, lot of waste gases are there. Now they are going to damage the atmosphere or the surroundings or the environment, right?
Yeah.
Yeah. So now if your air is damaged, the air pollution is there, air is damaged, so what will happen? It is going to affect the us also, right? Everybody which are present on the earth. So burning fossil fuel has two important problems with that, you can say disadvantages, right?
Yeah.
Now you must be heard about the word greenhouse effect.
Yeah. So global
Yes,
warming.
yes, greenhouse effect. So now this is a very general topic, but let's discuss little bit. So see, the Earth is basically getting warmed by the some radiations which are coming from the sun, right? Now
Yeah.
those radiation will come to the Earth, and then they are going back to the sun, right? In the space, you can say they'll go back.
Yeah.
They are reflected back. But what happens is, some of the radiations, they are reflected back, and they gets covered by the lot of gases. They are stopped by some of the gases which are present in the atmosphere. So they don't let them go back, or they don't let them to escape them, right? So
Yeah.
then what happens? Those radiations, they fall back to the earth's surface.
Okay.
So now what happens is, this is basically the greenhouse effect, because when those rays they fall back on the earth's surface, then the earth's surface it gets more warm, you can say,
Okay.
right? Now I'll give you an example. We have also covered this thing in photosynthesis also. Greenhouse effect. What was that? Greenhouse effect.
So greenhouse effect is when the carbon dioxide forms a thin layer
Okay.
over the Earth's atmosphere, and when the sun's rays enter the Earth's atmosphere, they
Excellent, Ron. Yes.
stop like bouncing back to and fro from it.
Right, you're right. So now, if you see, we can also artificially make a greenhouse. Remember, we had studied in photosynthesis also that thing. You make a glass, you take a
Oh,
glass house kind of a thing, and then you put plants there.
yeah, yeah.
Yeah, you remember? So now, if yeah, we can do that also. Now let's come back to the topic, the greenhouse effect only. So now, if you see, this is a natural way to keep the Earth's temperature as around 16 degrees Celsius. For basically, this is the temperature which is required for the survival. You can say. Okay. So now, if you see, uh, these gases, they trap the reflected lights, and they make sure that they fall back on the earth's surface. So can you tell me what are the effects of it?
So of greenhouse.
Okay, yeah, the effect of it will basically cause global warming, right?
Yeah, so the
Yes.
effects of it will the temperature will rise,
The
more
temperature.
floods, the sea levels will also rise.
Okay, there will
Due to
be
the ice.
heavy rains, ice caps starts melting, pests
Yeah,
can send the mosquito. If there will be lot of water, what will happen? Some of the harmful insects like mosquitoes, they will carry malaria. You can say, right? The
yeah,
stormy winds can come, while the cyclones will come. Okay, in some areas where desert are not supposed to be there, there will be deserts formed there. Low lying areas will have start having flooding in that area, right? These are the effects of
yeah.
global warming. And can you tell me, name two greenhouse gases?
CO2 and
Right, CO2. Now CO2, you say that it is a man greenhouse gas, right? Because
yeah.
yeah. And what about the second one?
So natural. This is like a natural gas.
Okay, so what is it called as? You must
Um,
remember these two names. It is methane,
oh, methane. Okay.
right? And where do it is basically released when the cows they break wind, right? You
Yeah,
have studied about this, but you must remember that these are the two greenhouse gases, carbon dioxide and methane. Okay, is it clear to you?
yeah.
Yeah. So now, in fact, if you see the scientists, they have realized that within a lifespan of 100 years, the Earth's temperature has increased approximately 2 degrees Celsius. That means it has become more warmer. So, this is the reason why the global warming is happening. Okay,
Yeah.
yeah. So, this was regarding global warming. So, now let's come to the acid rain. Can I change the slide?
Uh, yeah.
So, now let's talk deep about the acid rain. Now, if you talk about acid rain, I have already explained you that see there is, I'll make a flow chart kind of a thing only. There is basically the burning of the fossil fuels. Burning of fossil fuels means,
Um, combustion.
okay, combustion. Like I have explained you, lot of factories are there. Okay, they are causing, releasing lot of chemicals like nitrogen and sulfur in the atmosphere. So burning of fossil fuels means that these nitrogen is going to react with the oxygen. Okay, and it is going to form the nitrogen dioxide. You have to balance it. Nitrogen, sulfur.
Oh, so like,
Okay.
so
Yeah. Yeah,
I've heard of the nitrogen cycle.
right. So now if you see, it is sulfur dioxide is there. So now in this reactions also, like we have discussed, you have to, I'll just take, you can balance them also, right? Balancing you have to always do, otherwise what will happen? Because there are marks for balancing. Okay, in chemistry you have to make sure your equations are balanced anywhere. Understood?
Yeah.
Yeah. So now when you do the burning of the fossil fuel, so what is going to happen? Now these nitrogen and sulfur dioxide, they are going to get dissolved in the rain, water vapors, right? So then they are going to fall on the earth's surface. So we have trees, you can hear, and they are going to damage these trees, right?
Okay.
So
Yeah.
basically you can say burning of the fossil fuel produces acid rain, and this acid rain, it damages the damage wildlife.
Okay.
Is it clear to you?
Yeah.
And in fact it also causes lot of respiratory problems, which I have already discussed with you. So is it clear to you till now, acid rain?
Yeah.
Yeah, now if you see, when we burn fossil fuels, they also release certain particles, if you know, like, small particles they are released. Like for example, let's talk about diesel. Okay, we have it is quite dangerous because it releases lot of small particles which are harmful. Maybe it causes the respiration problems, you can say. Okay, so now what is the important thing is there is DPM, that is diesel particulate matter. Okay, in the,
Okay.
especially in the cities and the people who are living near the buses. So now this is a, you can say, real concern for the people, because these days the private cars, they have filters with them so that they can
Oh yeah.
remove these diesel particulate matter. You understood?
Yeah.
So that if you see, I am sure you must have seen in your car also, you must be having the filters at the back, right?
Yeah.
Yes. So now this is because of that only, so that to avoid air pollution, you can say, or you know, there should be less, few, you can say, few of them should be produced. So if there is plenty of oxygen for the combustion, because if it causes combustion, it is again going to pollute the air, right?
Yeah.
Yes. So now, if you see, like although you can say humans, they can cause damage to the environment, but they are trying to reduce also that damage. Right. So
Yeah.
now, if there are so many ways you can reduce the air pollution, now can you tell me which are those different ways in which you can reduce the air pollution?
So you can reduce the
Yeah.
air pollution by reducing your carbon footprint,
Okay. Good.
as well as
If I give you a three marker question, okay, you have to tell me the points, you have to suggest me the ways to deal with the air pollution. So you can't give only one point, you have to give more points. So what will you give? It's a very
so
major topic, right?
yeah. Uh, so you could reduce your carbon footprint as well as
Just think, by planting more trees, we can say.
oh yeah.
Yeah, okay, the planting more trees, or you can say by reducing the burning of the fossil fuels, the carbon footprint you have given us the this thing, the point. Okay, so in fact, right now, lot of countries, they're under pressure of decreasing their carbon emissions also, right?
Yeah.
Yes. So what else you can say? The
Um
nuclear power stations are there, right? So now they are also emitting the emitting the harmful chemicals under certain law only, like there's a particular value to release the air, or you can in fact before releasing the harmful gases into the air, you can treat them, you can put filters to them across the chimney, so that there should be less of the air pollution in the air, right?
Yeah.
Yes. So now can you tell me how can you reduce acid rain, if you see?
So, like, don't use as much. Well, we'll start using renewable sources of energy.
That's the one of the best answer I've got. Yes, using renewable resources. But now I'm asking for a three marker. Then what points will you give? Like if I tell you to write it for 3 marks, so at least you have to give 3 marks. So now you can always say, okay, using the renewable resources. The second thing we can say is not burning as much coal, because it's going to increase the levels of the sulfur in the air.
Yeah.
To treat all the factories and industries with the filters,
Yeah.
right?
As well as trying to, like, not use your car as much.
That's also nice. Otherwise, if you're using your car also, you can also say that uh, the cars, they can be taken care, like the cars can be fitted with the catalytic conversions. What are catalytic conversions? Basically those get rid of the acid, okay, from the exhaust fumes.
Yeah.
Okay, you understood? So the
Yeah.
exhaust fume will not release harmful gases into the air, right?
Okay.
Yeah. So in fact, you can build more efficient power stations also. If more efficient power stations will be formed, what will happen? Less harmful gases will be released into the air,
Yeah.
right? So in fact, the farmers these days, they add some crushed chalk to their fields also, so that if
Yeah.
the what is crushed chalk, you understood? A chalk, the crust chalk.
Gosh, joke. Yeah.
Yeah, yeah. So now if they put that thing in their on their crops, what will happen? The chalk has the tendency to neutralize the acid.
Yeah.
So okay, but the problem is it is, lot of time consuming, and second thing, it will become a very expensive fare for the farmer also. You understood?
Yeah.
Yeah. So now let's talk about the chemical reactions which can be reversed. Right now we were talking about those chemical reactions which cannot be reversed. But now let's talk about the chemical reactions which can be reversed. You understood?
Yeah.
Yeah.
So,
So now chemical reactions which can be reversed. Let's discuss about that. Do you think they can be reversed also?
yeah. So most chemical reactions can be reversed, but it takes a lot of energy to reverse them.
Very good. So that means they take lot of energy. Let's talk about the first reaction, if you know, decomposition.
Yeah.
What?
So,
Yes, decompose means breakdown, right? When you have a big large molecule, you are going to break down into the, you can say, smaller molecules. You understood?
yeah.
Yeah. So now when this reaction it happens, it usually takes lot of energy. So now that energy, when this large molecule will take, it will break down into the compounds.
Yeah.
Okay, so when it takes lot of energy, we call it as thermal decomposition. Okay, we call it as
Yeah.
when it comes to about energy. When this, suppose I am just giving an example, this is a large molecule. If it takes lot of energy, you can say, what happens? It breaks down into this compounds,
Simpler.
right?
Yeah.
Simpler
Simpler
substances. Yes. So now this energy, this reaction, we will call it as the thermal
Uh,
decomposition.
okay.
Why I have used the word thermal decomposition? because
because
it has,
thermal.
yes, it has taken a lot of energy. Now the second type of it you can say is, see, some of the compounds, they do not break by the thermal decomposition. So for that, the you can say the compounds required, those large molecules, they required electrolysis. Electrolysis is basically electrical decomposition. Now what is electrical decomposition? Basically you have a molecule, okay, the larger molecule, and you pass electricity out of that. You understood? You have a larger molecule, you have passed the electric current.
Yeah,
So what it is going to happen? It will divide into smaller ones. Now you understand?
yeah,
Okay. So now one more thing I want to tell you is, in electrical decomposition, it does not happen in the solids. Now have you studied states of matter?
yeah. So gas,
So
solid,
now,
liquid, and gas.
yes, so in solids, what, how the particles they are arranged? They are arranged at the fixed positions.
Yeah,
They are not going to move. They'll just vibrate at their own position, right?
yeah.
They are not going to move. So that means when they are not going to move, so when you pass electric current through them, there will be no reaction, there will be no decomposition, because they are at the fixed position. The arrangement is such that, you understood?
Yeah.
But when you pass the electric current through the liquids, okay, so now if you see in liquids, you have lot of free uh, ions. You can, you know what are ions? No.
Yeah.
Okay, good. So those ions are there. So now they can move freely. So that means, see, this way, if you see the arrangement of the solid is like this. They are packed. So when you pass electricity, they do not have the space in which these they can basically move, right? But
Okay.
when you take a liquid, the arrangement of the particles in the liquid is like this. So
Okay.
that means they can move. When you pass the electricity, what will happen? They will move. When they will move, they will collide with each other and they are going to break. You understood now?
Yeah.
But here they are just moving at their own position. So they don't have the place to collide also.
Okay.
Is it clear to you?
Yeah.
So we always say that electrolysis, this is important. The electrolysis or the electric decomposition will always happen in the liquids and not in the solids. Not in the solids because there are no free ions to move, whereas in liquids there are particles or the ions which can move, which can collide with each other and can form smaller, simpler molecules. You understood now?
Yeah.
So what are the different types of decomposition? It is the thermal decomposition and it is the electrical decomposition. And
Yeah.
sometimes what happens is, there are this was the first one, okay, this was the first one, A, I'll say. This is the B one, and the C one we can say is, there are some compounds which are not strongly bonded with each other. Okay, like if you provide little bit of heat, okay, if you provide little bit of the heat, they are just going to break, because the bond between the elements, you can say, that is not stronger. The compounds, the bond between, like, I have this one, this thing, the bond between them, this and this, is not stronger. So if I provide little bit of heat, it is going to split up. You understood?
Okay.
Like, I'll give you an example. The thermal decomposition of the let's talk about the hydrated copper sulfate. Okay, should I change the slide, please?
Oh, 1 second. Okay, I've screenshot it. You can
Yeah,
change
yeah.
it now.
Yeah, you've taken it?
Yeah.
Yeah, and one more thing. See, I am explaining you in terms of simpler molecules, larger molecules, so that you understand the concept. You understood now?
Yeah.
Yeah, but here there can be like you can say NaCl can be there, any big compound can be there. But since for your like you should not have confusion regarding the terms, so that is why I'm just trying to tell you that this is a larger molecule and it splits up into the smaller molecules. Clear?
Yeah.
Yeah. So now if we let's talk about one chemical reaction, that is uh, the de- uh, the thermal decomposition of the thermal decomposition of the I'll write it for you, the thermal decomposition of hydrated copper sulfate.
Okay.
Now this is a formula for copper sulfate. Okay.
Yeah.
Okay, now what happens is, and we know that this reaction, it is also a reversible reaction. It is important, you must remember this. Okay, what do you mean by hydrated?
So hydrated,
Yes,
well, well nourished.
well
Wait.
nourished, you can say water is there. Okay,
Yeah.
hydrated, hydration means water. So if you take hydrated copper sulfate, okay, and it is blue in color.
Okay. Pale blue. Okay.
Yeah, it is blue in color. So when you provide thermal decomposition, that means you provide thermal energy, the heat energy. When you heat it, this triangle is the sign of heat. Okay, you understood?
Yeah.
This is a sign
Yeah.
of heat. So now when you provide heat, what will happen? The water will start evaporating, right?
Yeah.
From the hydrated. So that means anhydrous means there is no water, and hydrous copper sulfate will be formed, and this is generally white in color. It is white in color. So you understood?
Yeah.
Yeah. So now when this hydrated copper sulfate, hydrated means water, in the presence of water it is been it undergoes thermal decomposition, then it forms the white colored anhydrous copper sulfate plus water. Now how do you test that these droplets, they are water? Can you tell me?
Uh, because so how can you tell the droplets are water?
Yes, because when you are providing heat, I'll tell you, when you provide heat to them, you place a cold mirror here. So now, when you provide heat, what is going to happen? The water is start evaporating, it will start going up, and when it touches to the cold surface, condensation will happen, and the water is going to collect it in the beaker. You understood?
Yeah.
You understood the concept of condensation, you know that, right?
Yeah.
Yes, so this is what is going to happen. So that means you get to know that it is water. Is it clear to you?
Okay.
So now this thermal decomposition of hydrated copper sulfate can also be used as the test for the water. Whenever you have to identify the water is there or not, you can always say by doing a test of the hydrated copper sulfate. That means if you provide thermal energy to the hydrated copper sulfate, the water will start evaporating and it will become anhydrous copper sulfate. Now that the water evaporated will touch the cold surface of the mirror, and it will fall back, it will be collected in the beaker. So this way you can test that water is being formed. Clear?
Yeah.
We have one more. This was one example. The second example, let's talk about the thermal decomposition of the the copper carbonate. Sorry, you understood? We have copper carbonate. What is the copper carbonate we have? Okay, now copper carbonate is basically green in color. So now when you provide thermal energy, that means when you heat it, what happens is it forms it forms Copper oxide. What is the formula of copper oxide?
I'm not sure.
Okay, it is copper oxide is CuO. Okay,
Oh,
copper oxide plus carbon dioxide.
okay.
Okay, it is basically CuCO3. CuCO3. So CuO is formed and carbon dioxide is being formed. Okay, so now this is green in color and this is black in color. So when you heat the copper carbonate, so this copper oxide is formed and carbon dioxide is there. So now if you see, we have prepared copper carbonate, we have prepared a larger molecule. So now you have to bring them back to the reactants. This is what we are doing right now. The products are being transferred into the reactants, right?
Yeah.
We are talking about chemical changes which can be reversed. Yes,
Okay.
we are talking about that only, right?
Yeah.
We are talking with those about those chemical reactions which can be converted back. So the hydrate one, where it has water, it has basically these are the products, you can say. They are getting back to the reactants.
Okay.
So we have copper carbonate which gets transformed into the copper oxide and carbon dioxide. And for doing the test of the carbon dioxide also it can be used as whenever you burn it. So now if this is your test tubes, so when you are going to burn it, what is going to happen? The copper oxide, the black thing will be formed here, and the carbon dioxide will start coming out of the tube, and it will start going into another tube. In that tube we have lime water. So now if in that lime water it causes bubbles, that means carbon dioxide is present.
Okay.
You understood now?
Yeah.
So then now if you see, you can do the test for carbon dioxide also.
Okay.
Okay, so now we have one more. Is it clear to you till now?
Yeah.
Yeah, we have the third reaction. We have one, that is potassium permanganate. Potassium permanganate. We say it KMNO4. Okay, but okay, that's you don't remember it. That's okay. So if you have potassium permanganate, that is basically purple color. It is kind
Okay.
of
Like
purple color.
iodine. Like iodine.
Yeah, the
Yeah.
purple color is there. So when you provide thermal decomposition, that means when you provide heat, it forms the permanganate only. But the thing is, it releases the manganese oxide, manganese dioxide, and oxygen. Okay, here we have potassium permanganate only. But what happens? The color changes.
Yeah.
Okay, the color becomes of manganese dioxide, it is black in color. You understood? And
Yeah.
like if you are, you can just say take a beaker and you are just heating this mixture. So what is going to happen? The oxygen is going to release here, and what is going to be left? You will be left with this thing, the potassium permanganate and magnesium dioxide here. So now this magnesium dioxide, it has a black color. So instead of purple color, the solid, you are going to see the black colored kind of a thing.
Okay.
Clear? Is it clear to you?
Yeah.
Yes. So, can I change the slide, please?
Yeah.
Yeah. So now, if you see, we have one more example. You can say the fourth example is of calcium carbonate. Calcium
Okay.
carbonate. Now, calcium carbonate is basically white color. When you heat it, okay, when you heat it, what is going to form? Calcium, calcium oxide.
Oh, so yeah,
That is
okay.
calcium oxide. I'm going to write the formulas also for you, so that, and carbon dioxide will be released.
Okay.
Okay, now this calcium oxide, you also call it as the lime.
Okay.
You understood? And what is calcium carbonate? We call it as limestone.
Okay.
Is it clear to you?
Yeah.
These are the general names for them, the common names for these chemicals. So calcium carbonate, it is also called limestone. It is being heated and calcium oxide and carbon dioxide is being produced. So last reaction, we have one more reaction. That's the last. There are 5 reactions. Rohan, you must know about these.
Okay.
Okay, so this is the last one. That we have cobalt chloride. The formula for cobalt is CO, right?
Yeah.
Yes, and chloride is Cl2. So now if you see, when cobalt, it is basically blue in color. So when it reacts with water, so it is going to form
Um.
cobalt. No, no, this is
Oxide.
basically, no, the H2O. That means it is going to form hydrated form. Okay, the water is going to attach to this thing, and it will be of purple color. Okay,
Okay.
so now this purple color, if you add more water to it, that you can just say you add 4 molecules of water to it, it is going to form COCl2.6H2O. So that means pink color will be observed. You can see the colors.
Yeah.
Yes. So if now you understood, like I'm adding 2 water molecules, it is going to turn into the purple color. When I add more 4 molecules of the water, it is going to turn into the pink color.
Okay.
Okay. So now if you see if you heat the hydrated forms of the the cobalt chloride, it reverses the reactions. You understood now?
Yeah.
So you can't say that like this the cobalt chloride, it is not coming back to the anhydrous form. Now it is only the water is being added to it. It is not, the water is not being removed from it. Can you see that?
Yeah.
Yeah. So that, now can I say that it is not basically a typical decomposition reaction?
Yeah.
So now if you take out water from it, that means it will become a dehydration reaction. Yes.
Yeah.
Yes. So the heating should be, like, to get back to this cobalt chloride, the heating should be done very gently.
Okay.
Okay, because otherwise it is going to disrupt the chemical also.
Yeah.
Okay, so now is it clear to you? Like
Yeah.
there are papers also, cobalt chloride paper, sorry, there is a this thing paper. If you put cobalt chloride on the paper, okay, the filter paper will turn pink. But when you put, yeah, when you this paper, it will it sorry, this is there, right? So it will turn pink. You understood? You have a filter paper and you put the drops of these, it will going to turn pink. But if you provide little gentle heating to that paper, what is going to be formed? The paper will start turning into purple color. Similarly, if you
Okay.
provide little bit of heating to it, it will start turning out to be blue. Oh, you understood?
Yeah.
Yeah, so you can get them into the back also. But we can't say that it is a pure decomposition reaction. Instead of that, we can say that it is a dehydration reaction.
Okay.
Is it clear to you?
Yeah.
Any doubts till now? Anything you
No.
want to ask me?
No.
Sure?
Yeah.